The Romans built incredible structures more than 2,000 years ago. Temples, aqueducts, harbors, and amphitheaters, many of which still stand today. But there's something truly remarkable about their concrete. It has lasted far longer than anything we build now. Our modern concrete begins to crumble after just decades. So the big question is, what was their secret? And why have we lost it? Today, we're diving deep into the mystery of Roman concrete, the ancient recipe that modern science is still trying to unlock. To understand Roman concrete, we need to first look at how important construction was for the Roman Empire. Rome wasn't built in a day, or even a century. Their engineers built roads spanning thousands of miles, massive aqueducts to bring water into cities, and enormous public buildings. Concrete was at the heart of it all. Unlike earlier civilizations that mostly used stone or bricks, Romans developed a new material that was cheap, strong, and moldable. This gave them the freedom to create arches, domes, and vaults that were architectural marvels. One of the most famous examples is the Pantheon in Rome, with its massive, unreinforced concrete dome, still the largest of its kind after nearly 2,000 years. The Roman Colosseum is another iconic structure that relies heavily on concrete for its foundation and core. So what was in Roman concrete? The main ingredients were simple: lime, volcanic ash, and water. But not just any volcanic ash. They used a special kind called pozzolana, named after the town of Pozzuoli near Naples. Pozzolana is rich in silica and alumina, which react chemically with lime and water. This reaction creates a mineral called calcium silicate hydrate, the glue that holds concrete together. But Roman concrete had an even more remarkable ingredient: seawater. Roman engineers used seawater in many coastal structures, like harbors and piers. And this wasn't a mistake, it actually made the concrete stronger over time. This was crucial for their massive maritime infrastructure, which could survive the harsh conditions of saltwater, waves, and storms. For centuries, modern scientists couldn't figure out why Roman concrete was so durable, especially underwater. They thought saltwater would damage concrete, but Roman structures proved otherwise. Recent studies, using electron microscopes and chemical analysis, revealed the secret: a chemical process called the pozzolanic reaction. When volcanic ash and lime mix with seawater, they trigger the formation of rare minerals like aluminum tobermorite and philipsite crystals. These crystals actually grow and fill cracks in the concrete, making it self-healing. This natural process stops cracks from spreading and strengthens the concrete over centuries. It's like the concrete repairs itself slowly but surely. Scientists have taken samples from Roman harbor structures and found these crystals forming even after 2,000 years. This discovery is changing how we think about ancient materials and construction. Modern concrete mainly uses Portland cement, which is different from Roman concrete. While Portland cement is fast-setting and widely used, it doesn't last as long, especially in marine environments. It tends to crack and erode after years of exposure to water and weather. Roman concrete, on the other hand, improves with age. Scientists estimate that some Roman harbor structures have grown stronger after 2,000 years underwater. This makes Roman concrete a true engineering marvel, one we still can't fully replicate. Some researchers believe that if we could combine the strengths of Roman and modern concrete, we'd revolutionize construction. But if Roman concrete was so amazing, why did the recipe disappear? The answer is partly historical. After the fall of the Roman Empire, many technologies and building methods were lost or forgotten. Concrete fell out of favor in Europe for centuries. Instead, builders returned to stone and brick construction. It wasn't until the 18th and 19th centuries that concrete made a comeback, but the original Roman formula was long gone. Additionally, the Roman formula required specific volcanic ash and seawater, materials not available or practical everywhere. The knowledge became localized and eventually faded from common use. Today, scientists are racing to understand and recreate Roman concrete. They're studying the chemistry in detail, hoping to develop new, sustainable building materials inspired by the ancients. Why? Because making concrete stronger and longer lasting can reduce waste and the carbon footprint of construction. Concrete production accounts for around 8% of global CO2 emissions. If we can copy Roman concrete, we could build eco-friendly, ultra-durable buildings, bridges, and even underwater structures. Imagine a future where infrastructure lasts for centuries without major repairs, saving billions in maintenance costs. Some companies and research teams are already experimenting with volcanic ash and similar materials. They're developing geopolymer concretes that mimic Roman durability. This is more than just curiosity, it's a necessity, as climate change and urban growth demand stronger, greener construction methods. We could soon see ports, highways, and skyscrapers built with concrete that lasts thousands of years, just like the Romans dreamed. It's a perfect example of how ancient knowledge can inspire future innovation. The mystery of Roman concrete shows us that even thousands of years ago, humans achieved incredible feats. We still have much to learn from the past. If you enjoyed this deep dive into ancient technology, make sure to subscribe. And tell me in the comments, what other ancient secrets or inventions should we explore next? Thanks for watching.